Welcome to solverfy.
In this case, we have a hydrogen atom which has an electron that exists in n equal to 4 state, and the electron then makes a transition to the ground state and emits a photon. So let's take a hydrogen atom where the electron is initially in state 4, makes a transition inwards, and then now it exists in a state which is 1, which is our ground state. So this is 1. Imagine, so the amount of energy in this case should be equal to okay, and now this energy will be taken over by the photon which is emitted. The energy of the photon we know is always given as h into f. From the conservation of linear momentum, we know that the momentum which is taken, the initial momentum of a system is 0. So the final momentum of the system should also be equal to 0. However, the final momentum of the system is made up of two different kind of momentums, which is the momentum of the outgoing photon and the recoil momentum of the hydrogen atom. So that means, so let us write this way: the initial momentum of the system, because everything is at rest, is 0. So the final momentum should be 0. This is conservation of linear momentum. The final momentum is, however, made up of two parts, which is the momentum of the photon. So let me write P photon plus the momentum of the hydrogen atom, in this case, which is the recoil moment. So the magnitude of these two should be equal. One should be positive and another should be negative. So we can say that the magnitude of this momentum should be equal to the magnitude of the hydrogen momentum. So hydrogen momentum is the mass of the hydrogen, which is equivalent to mass of the proton, because electron is almost negligible, into velocity of the recoil, p is equal to mv. And in the case of photon, which is light, it is hf, energy over c. So from here we get that v recoil so we denote recoil as vrc, should be equal to hf over mpc. Now what is hf? Hf is the energy of the photon, and energy of the photon is exactly equal to the energy difference between the two states. So we can write that as E14, or in our case just delta E over mpc. So V recoil is equal to delta E over mpc, and this will be equal to, as we know before, minus 13.6 EVs divided by 1 over 4 square. So you can directly take the inverse. Again, let us write it in this way. Now here we have made use of the formula that En is always equal to minus 13.6 EVs divided over n square. So all of this divided by the mass of the proton, which is 938 MeVs, into velocity of the light, which is c, and together it comes out as 4.1 meters per second.